Hello and welcome back. Today I have a frequency counter. It is from the early 70s and it is from the brand Yaesu. It's the YC-355D and it has NIXIEs. From the front it looks like this. You can see it's an older design. Well, 70s, it has 1, 2, 3, 4, 5 NIXIEs. You can switch the frequency here. Yeah, the front is not that good anymore, but there is still some text, but I can show you how it's supposed to look. This one clearly looks less good. Well, we have the input. Here it is, I believe, up to 35 MHz, and if I switch it down, it goes from 30 all the way up to 200. We have the switch here for low and high impedance, on-off switch. And here we have a trick. This is the kilohertz megahertz switch. And what it actually does, because it goes up to 200. So with 5 digits, you don't have that much to see. But they have a trick. If you switch, it adds 3 digits, but it just shifts. So you actually have 8 digits like this. And this window just moves to the front or to the back. So that's kind of smart. Clearly it had better days, but we can all clean that. And if we look in the back, you can see that there is a little modification done. This is kind of scary, this plug, but it is by design and it's for different voltages. I found them for 110, for 117 and all the way up. This one should be for 220. There is a switch here for DC to AC, so 2 of the pins are AC, 2 of the pins are DC, and you can feed it around 12 volts. And I think it should be between 11 all the way up to 14. This hole was always there, but I have not seen that there is an option. But here, 10 MHz, someone did a 10 MHz reference, and I wonder what is in there. So I have the power plug right there, and it really is, well, it's non-grounded, so I can't use this plug anymore. But this cable also almost looks like a DC cable, and this is indeed the plug. And if you think, hey, I recognize this plug, yes, me too. I have here an old CB, and the plug just fits in the microphone, and then it becomes kind of scary to use this plug. That 10 MHz reference input, that's kind of interesting. Also because the internal crystal is 1 MHz. So, or they made some sort of divider, or I don't know, I need to see what they have done to achieve this. I like it. Can connect it to my GPS DO. Well, before I open, this feels good. This connector will just need some cleaning. The on-off seems to work. The kilohertz megahertz, the shifting works. But the high and low impedance doesn't work. So I'm not sure if the switch is broken or that the former owner just used it always in high or always in low impedance and just decided to lock it. Or simply the switch is broken. I hope that NIXIE still work. But before I switch it on, I just want to have a look inside. I already saw some pictures of how the mainboard could look very good and how the boards can look bad. So I wonder what I will find inside. And of course interesting to see what they have done with the 10 MHz to 1 MHz. So what are we going to find inside? Ooh, a lot of dust. Here is the switch for high and low, so we probably have a little prescaler here. The transformer, ooh, the paper is gone. but hopefully it is set to the right voltage. We have here really two super small wires for the AC, I think. And then we have here the wire for the DC. Yeah, it doesn't look that good, to be honest. And here we have the 10 megahertz. And it is in the place of the crystal oscillator indeed. So they probably replaced the whole. So that is the top. What does the bottom look like? Are there many modifications done? A bit in the power supply. And the high-low impedance switch here. Well, the cables are also disconnected. I think this is done in purpose. But the kilohertz, megahertz still connected. Usually I test before I clean, but this time I was kind of scared that it would maybe blow up because the transformer looked bad with the broken paper. It has this very old power plug, which is also nice because it doesn't have grounding, so I don't need to worry about any ground loops. But yeah, let's try it. I will use my my AC power source to 220 instead of the 230, 235 we have here, because it is designed for 220, this one, and I don't want to push it too much to the limit. Well, it is a lot more shiny than it looked before. Also, we can now see it's not a C, but it is the D model. I'm not even sure that there is a C, but yeah, now I see clearly it is a D. And the power plug is in the back. I switched it to AC, so here it is. Let's put the 2 megahertz. Because the switch here doesn't really work, I just do an inline terminator. We'll connect it to my external reference, just to one of the distribution amplifiers, and oh, it's actually pretty good. It is indeed 10 megahertz, so that oscillator they built themselves works pretty nice. Let's see if we now can get to that kilohertz, so we can look here at the back, because this is not stable. We can see that the gate time changes also, and ooh, this is not bad at all. So here we have the 10, and this is below. Pretty nice. So we can adjust that. Cool, that seems to work. I also wonder now if the external reference works. And yeah, you can see. Let me lift that again. And what if we put the external reference? I will use the cable that they gave me with it, just to be sure that, because it looked like they did something in it. I don't see it change. Maybe we need to switch it off and then switch it back on. No, it's still the same. It's 40 Hertz. Then I'm going to use my own cable. I thought maybe they built something in this plug, but now I will just use my own cable. And then it should be immediately spot on. No, still that 38. Do I need to put, is it too much signal? Do I also need to have my terminator? Now I put with the terminator. No, it's no change. Need to switch it off. Okay, well, the external reference, we need to look at that later, but we can still adjust the oscillator. Let's see how high we can go. So let's just get one of my oscillators here. This is the WBSG2. Let's switch the to. So 1 megahertz. I'm not sure if you can see. Maybe I need to. 2, 3, 4, 5, 6. It's fast. 10, 11. Well, let's go a bit higher. 30. It is really very, very little that it. Okay, after 35 we need to switch over to this one. Yeah. And then of course if we go to kilohertz. It's difficult to read. I really need to get used to this, to see exactly how much it shifts, because if we need to keep track of the dot, then the dot is at kilohertz, so this is the whole 30 megahertz, and then okay, let's go higher. 40, 50, 60, 80, 100. It should go to 200. 200, here we have it. 210 even. 40, 250. Here it starts to go. So 250. And yeah, now we are 750 hertz off. Yeah, that makes it. Oh, yeah, I think the frequency need to go a bit lower because it is missing counts, so sensitivity goes down a lot. Back to 200. And now we are almost 600 hertz off. Let's go back to 10 and we can adjust. But I'm of course off now. Well, it's pretty well adjusted. without external refrigerants, still spot on apparently. Well, before we start adjusting, it's maybe interesting to see what they actually did. So they removed here the 1 MHz crystal and they built here this oscillator themselves. So usually they have the 1 MHz crystal right here. Now they have here a 10 MHz crystal. And they built a little oscillator. Here is the 7486, which is an XOR gate. So they probably built an oscillator here. You see here the external input comes in here. I see here a little transistor and a little cap. So maybe a part of the signal just goes in. And here we have a flip-flop, the 7474. So partly goes directly into the IC, and probably with one they charge the capacitor and to open the transistor, so it goes through the port. And if not, then it just uses only the oscillator signal. Here we have a decade 7490, which is very commonly used to divide by 10. But you can also divide by 2 or by 5. It's very popular. It's fast enough to do this 10 MHz. Well, we can measure, so somewhere here we should have 10, and then of course on the output we should have 1. Well, my scope is here, so I'm not sure it is good to see that. Well, we have the crystal here, and so into the flip-flop, if we have external or not, somewhere we should have a signal. If I start probing, yeah. Here we are on one of the pins of the flip-flops, because I got 5 MHz instead of 10. So if I get another pin, I should have 10. Yeah, here I have 10 MHz. So this one comes from the oscillator. And well, it's just a normal signal. And of course, if I go to the decade, I should have 1 MHz. Which I have here. I have 99.997. Yeah, and that makes sense. It is a little bit lower because then in one cycle it can do more counts. That's why it says it's more. So, but we can just adjust here with the trimmer. I can adjust it in 2 ways. Here is my pot. I can just put it on the output, which I will do. It's just TTL output, so it's loud enough. I don't need to worry too much about the impedance. If you do this on a crystal, of course, you will just mess up the oscillator because your impedance changes like you're adjusting the trimmer. But now I'm just on the TTL output, so I don't need to worry. Look, we can see it is too low, and it's actually exactly the same as the oscilloscope set, 997. And but I will also be adjusting on the front because I know that I have exactly 10 MHz from my GPSDO. Of course, you don't use a normal screwdriver. I bought these ceramic ones. These are better than the darker blues. This is the CD25. It has a good head, it will fit. Hopefully at this angle you can see the counter and my adjusting, because otherwise my hands will be in between too much. It is of course very sensitive. Oh, actually not. They built this very nice. Here we go, lower, lower, lower. So I'm going up the other side. Almost there. This is very nicely built. The trimmer really, it's almost like a 10-turn pot. This is very nicely done. Yeah, don't let you fool yourself, because we are already here in the hertz, so we are here below already, because with so many digits sometimes you think, oh, it's way off, but here is the dot. Okay, I think with the crystal oscillator this is as good as it gets, and also it is of course very temperature sensitive, these things usually. Yeah, here it goes. But this is as close as we can get it to 1 megahertz. And if I switch it over, it thinks it is spot on. Well, it actually is, because the digits that you see here are here on the end. Look at this. And now put it an extra digit. So we have here megahertz, kilohertz, hertz. So this is below. Pretty cool. I can even do an extra digit. Look at this, megahertz, kilohertz, hertz is 0.2. Yeah, nothing wrong here. So it's a new build oscillator that the former owner did, actually works pretty well. It was very easy to adjust the capacitor, so that is I like from his design. The flip-flop doesn't work completely when you put the external reference, but I just need to check. Maybe the transistor doesn't charge the cap, or I don't know what is the problem, or the flip-flop itself is just broken, although it does pass through the original signal. And well, the rest of course works. The oscillator works, so that IC is working. Also the divide by 10 is working, because we can clearly see we get 1 megahertz. So that is all not a problem. But I will just leave it as it is, put it back together, and then we have a closer look how it looks when it is clean. So hopefully now it's closed. It is just as good, because those little crystal oscillators are pretty sensitive. But if we switch it over now, it seems to be like 8 hertz off now. Now it's closed, so it is kind of sensitive. But of course, with when it gets warmer, it will change also. So I need to get this external reference working. But yeah, it's a big improvement, because it was like 40 hertz off, and now it will go down when it heats. Wow, it looks amazing. It is all back to a shine, and look at this, even I was able to get this to its original color, and it is a nice piece of technology. The only thing I would like to do is find out about the external reference, and then it would be great, although it is not original, so it should work as it is. It is a pity that the front is almost not readable. It is very light, and I'm not sure if I put my light differently it would visible, but it is very light brown. I was not able to improve that. Maybe I can do that with a sticker, but then I prefer to keep it original. So that was the Yaesu YC-355D from early 70s. Hope you enjoyed that. Thank you for watching, and I hope to see you next time.